and data cleaning and processing, then develop a machine learning model, evaluate it, and build a streamlit web app for use. The original dataset was from Cabo. It was quite big. It had like 1.6 million entries and 23 columns. So I dropped all the unnecessary columns and remained with about 8, which is name, like title. This is like the broader job category. The role, this is like the exact like job role. The category, like title is like role is the contact phone number, qualifications. These are the education like qualifications like a master's degree, PhD, and all that. Experience, this is like the years of work experience. And skills, these are the skills the candidate possesses based on the job role and title. And company is a list of company names. So I wanted to use like this to train a named entity recognition so that like if you upload like a CV, it can extract like names, titles, job roles, contacts, educational qualifications, years of work experience, skills, and maybe like some of the companies you have worked for. So for my APA, like I wanted like to see like some of the popular job roles that you can see like you have like nurse, practitioner, back developer, social media, account executive, and all that. And here's like one cloud for the skills frequency. You can see like you have quite like skills related to software, maybe data science, such as Python, machine learning, project management, data analysis, and all that. Okay, for the model selection, because an entity recognition like requires like high accuracy, I wanted to use transformers, and I went with like the bidirectional encoding representation of transformers. These are the bats. So a distilled bat is a version of the bat, like it's just that like the traditional bat model is quite range and slow. A distilled bat like is basically a smaller version of it. So it is lightweight and efficient in that it is above 40% smaller and faster, but it can retain like over 95% of the traditional bat accuracy. So transformers are quite good at like understanding contextual meaning in resumes, which is quite good in like extracting entities. So and also like the Stillbird is like relatively easy to install on web apps like Streamlit. For the data preprocessing steps for my model, so the first step you need like the raw text. This is like the text data frame from the data set. Then you need like to tokenize it, like add biotagging. I will explain this later. Then like from the biotags, you do numerical encoding to convert the tokens to integers, and then you do embedding conversion where like you convert like the integers to like vectors. So for the text preprocessing, so like the original text will look like this. These are sample of the data frame where you have like the name, title, role, contact, email, experience, qualifications, a list of skills, and like a company they worked for. So for tokenization, my sample output looked like this. So you want to like extract like the name, you can see here, the title, the role, API developer, contacts, all that. Okay, for transformers, like the tokenization is not like the traditional tokenization where like you extract like word for word, like you need to like group like some things. So this is like my sample output for the tokenized like text from such a data frame. So next thing was like to apply biotagging. So in biotagging, you need like to let's say like for an entity like a name, most people have like two names. So in this case, like you have something like Stephanie Morris. So the first Stephanie is like assigned a B tag, which denotes like the beginning of the entity, and the next one is assigned like an I name or an I tag, which denotes like the continuation of an entity or like its inside. And the O denotes like outside of an entity, or like no entity. In this case, you can see it, for example, in like at the beginning, there's like this CLS token which is added, like this like has no affiliation to any entity. And also at the end, you have like this SEP token which is added and the padding. So for the padding, like for this model, you need like to ensure that all like inputs is of the same length, because you can have like say like for the first input, like maybe someone had like a lot of skills and the second one they have like less skills, so it means like there will be like a token length mismatch. So padding is added like to ensure like the input to the model is of the same length. Then you have to do like numerical labeling, whereby like the tokens, like the BIO tags, are actually like assigned like numerical labels. You can see like 0, 1, 2, 3, 4, all that. So you can see like the B tag for the name is assigned 1, and the I for the name is assigned 2, and so forth until the last tokens. So these numerical integers will then like be converted to integers or vector, like to vectors or logits. In this case, using a map in the model. It will automatically do this when like before training. So from the dataset, I then like did a train test split. This is like a sample because the dataset was quite large. I shrunk it to about like 100 entries of each job role and ended up with about 7,600 entries for the training. So for my modeling results and evaluation, okay, these are some of the like scores I got. So you can see like for some things like contracted experience, like there was some overfitting and some entities like role, like the performance was not that good, but like it was at least like 60%. For the loss analysis, this is like a plot of the training and validation loss curves. So you can see like yeah, for like the training loss like dropped quite significantly because like on some entities like there was overfitting. Yeah, but it was decent. This is my confusion matrix. Okay, the next thing is like a Streamlit web app. Let me see if it has opened. Oh yeah, so this is my Streamlit app. I think I can do like a demonstration. Let's say like this one. Okay, let me post like a sample job description. Let's give it some time. So you can see like I'm getting like a match score of about 50%. And here are some of the matching skills. Okay, the extracted like skills are not like quite like there, but you can see like you have like things like statistics, communication, SQL, data visualization, data analysis, machine learning, data visualization, Tableau, all that. Yeah, yeah, and this is like a highlight of some of the skills. Okay, the model is not like quite perfect, but like yeah, there's like room for improvement, but like it can extract like some skills, and entities. So some of the challenges I faced, okay, I was unable to train the entire data set due to computational and time limitations. Even with a smaller data set, like my training took like almost 7 hours, and you have like to do like multiple times. Yeah, then there was model overfitting on some of the entities, and the Streamlit model app like did not like behave like quite like I expected. And for future improvements, like also the dataset like was not like that ideal for such a case use for named entity recognition, and a large diverse manually annotated dataset would be a much will be like way better. Okay, the training can also be fine-tuned like on like specific domains, like say you can fine-tune it on like STEM to improve the accuracy. You can also add like support for multiple languages, resumes. You can do integration with job ads or like applicant tracking systems, and you can build a better dashboard. So in conclusion, I managed to build like a natural language processing like model to extract like entities and score resumes, and build like a simple Streamlit interface for use. Yeah, so I believe like that's all. I think I've shared like my GitHub repository on the chat. So I don't know, like any questions, suggestions.
You want to start?
Hello.
Hello.
Yes.
Okay. That's fine. Um, why did you not try other transformers? Okay. With other models. Yes. Why are transformers not other models? So we can see the comparison. Mm-hmm. Moses?
Yes. Yes.
The question is, why a transformer? Um,
Okay.
why
Yeah.
not
So like
try other models and see how they
yeah,
compare?
yeah. So like I wanted to use a transformer because like I found out like they would be like the perfect like suit for this particular role. Yeah, because like before this, like the other models, they use like FID vectorization like to score and like rank resumes like that. But like for named entity recognition, like I found like most resume passing like systems they use like transformers.
So from a literature review, that's how you decided, okay, I'm just going to try a transformer. I won't, try anything else. But don't you think, or are you saying you already tried them and you've just not included in your presentation that they were not giving you favorable performance?
No, I did not try other like transformers
Mm.
because like the others like they were like sentence transformers. I found like that one would be like more suitable for like question and answering like systems like that.
Because I've seen other people
Yes.
use sentence transformers and they get actually good results. So you
Yeah, I
just
found like
settling
those are
on
used
one.
like for like Q&A like purposes mostly.
Mm. Okay.
Yeah.
Uh, and then why are we biotagging? Maybe just something to check also. Um,
Okay.
what data did we feed into the system, or rather for the
Yes.
training? What were the columns?
Okay, for the training, you
Mm.
can see like this. Okay, after the biotagging,
Mm.
like this B name, I name, this like are the tags. These are the ones which are then converted like to numerical repos like the 0, 1, 2, 3, 4 and others. But then this like when you feed them to the model, it will automatically like convert them to like vectors. Like it has like a vector map, it automatically does that.
Okay, I think maybe I'm not also following so much because it would be best if you showed an illustration or a representation of that vector map, what it would look like, so that
Yeah,
whoever, because personally I've not done such projects before, and I would not say I completely understand how your model is working under the hood.
yeah,
What's a name entity recognition, and what are we comparing the inputs to the outputs, so that we can, because the other question that is leading me to that, why would we feed something like a name of a person to the model?
no, you're not feeding the name. Okay, so like on this like slide, you can see like the name is Stephanie Morris.
Mhm.
It has been assigned a label B name and I name. Like the first name is the beginning of the name, and the second one is like the inside of the entity. Like the entity is the name, but it will
Mm.
be having like two labels. But because like you cannot feed like the B name and I name, because like as you have said, these are like text based, we need to assign these labels. You can see like you have the token, which is like Stephanie, and the label, which is like the B name. You also need like to convert like the tokens and the labels to like numerical integers. You can see like the tokens are converted like to these integers like 101, 11, 49, and the labels are given like these numerical also integers like 1, 2, 3, and all that. So what is being fed is like these numerical integers, the 101, 11, and all that, and
Okay.
these like the labels. So these are the numerical integers which will then be converted to vectors. So we are not feeding like the actual like name.
Go for it, Mercy.
So Mugambi, for me to
Yes,
understand, so the model will pass through all the text in that CV, and then it's going to
yes,
categorize and say this is a title, this is a name, this is a what, and then it's going to kind of like separate only the skills and do the skills matching, right? That's what's happening under the hood.
yeah. For the like matching and scoring is supposed like to use like the skills, the extracted skills like from the CV and the job description at like a creator score. Yeah, but it's like for like if you want to use it like for like an individual, you can also like put your other details like your name, skills, experience, like titles, some of the companies you worked for, and all that.
So you're doing a job skills match. So in that case, you would take this labeled stuff, like, your skill one, skill two, skill three, and then you're comparing it to what's in the job description. Is that what you mean by the match?
Yeah, even on the job description, it will
Mm.
also like
Do
extract
the same.
skills from the job
Mm. Mm.
description
Yeah.
and from your resume, and like do a match and give you a score.
Okay, that's fine.
Yeah,
My concern is just some of the data points that is being fed into it. So, for example, I don't think job
yeah,
descriptions always have things like company. Because do we say if you've worked in Capital One, uh, Lehman Brothers, etc., then you're more fit for this role? So,
yeah.
is that data relevant to doing a job skills match? Because a job skills match, in my view, would be more of experience as well as the
Yeah.
skills themselves. Nothing on your name, nothing on the company you've worked on.
So is the model fed all these labels, or is the model fed only this the text that has been labeled as skills?
Okay, so for the training,
Mhm.
I use like the text like this one. This is what I use like for the training. After that, it should be able like when
Go back
we upload
kindly
like a
to the, yeah. No, no,
yeah,
no. Yeah, there. Yeah.
yes, yes. So like this is my training text.
Mm.
Yeah, because even like from a CV, it should contain like things like this: name, title, role, maybe the contacts, email, qualifications. This is like the degrees, PhD, and all that, diplomas. Maybe there's like experience and skills. Yeah, so I wanted to use this like to train it to be able to recognize like these entities like skills, experience, the educational
And role
qualifications,
and title.
email, like
Yes.
contacts, role, title,
No,
like
but
that.
email, Mugambi, do you agree
Yes.
that email and contact and name and even maybe company won't be in the where is the job description data? Because this is the resume data from what I understand. Is it right?
Yeah.
So where is the job description data?
Like, but like, okay, for like the resumes and the CVs, they basically almost like contain the same things, like because from the job description, mostly you'll be needing like skills or maybe like the experience required and the educational qualifications. So for the job description, like this is mostly useful. But if you want it like to use it for yourself, like maybe I want to enter like a job description and like see how I fare. Like I I thought like these other like entities would be like useful. Maybe like this. Yeah.
Okay. Maybe I'm questioning too much because there's something I'm not getting clearly. What when
Yeah.
we say 51% match, what is
Yeah.
the match against? Is it, let's say, number one, Christopher Duffy?
Yeah.
When we feed this data, it
Yes.
is 57% match to the job
Skills
description.
needed. Like the skills needed.
And where is that skills needed written? Because this data here would be, these
Yeah.
skills here are the skills for this Christopher. Is it?
Yeah.
So
Yeah.
what are we comparing to their skills? Like what's the label data of sorts?
Yeah. But this like the this is like a data set, like it contains like a list of skills they contain, they possess like these candidates.
Yeah,
Yeah.
so this candidate, they already have this skill. They have an AWS, cloud
Yeah.
skills. And then we want
Yeah.
to check from this job description. This job description has listed Azure, AWS, and SQL, but this person
Yeah.
only has Azure and SQL. So that would be a 10% or a 50% match. So now, where is the data to which we are matching the individual's skills? That's what maybe I'm not getting clearly.
Oh, okay. Oh, so for the skills, like, okay, the skills is like, it's quite a lot. So, like, I wanted to use like these skills they possessed by like all these candidates. Like, they're about like 376 unique like job roles, like each with a list of skills. So, like, all those skills, like, they would also like be mostly like present in the job description.
Yeah, it's just that it's not coming out here where the data of job description is coming from. I'm not even seeing it here. That's why maybe the confusion I have. I don't know if
Oh,
Mercy,
so you
you
wanted
have
like
it.
for it to have like skills for the candidates
And
and like
then
for the
skills
job
for the job
description.
description, because that's essentially what you're matching. Okay, not you're not only matching skills, you're also matching the title, the role they've had in the past, as well as their qualifications to what's listed in the job description.
Yeah, so like yeah,
And
so
I
this
think I've
just like
seen that
contain
data
like
somewhere. Maybe you
skills.
need to
Yes.
interrogate this further. There is this is data for candidates, but then there's another data set for job descriptions. Yeah. And
No, okay, for this data, like
I
there was
think
no
he
like
doesn't need
extra data for the job
that one
description.
because what
It
he's
just like
doing,
had like
it's a
skills.
recognition model. So you're training the model to be able to recognize a name in a CV, a title in a CV, the role in a CV, the contact in a CV, and all those things in order to extract the skills
okay,
and then
okay,
compare the
okay.
skills to the JD. That's why on his Streamlit, he uploads a JD. So it's necessary for us to have name, to have title. You're training the
The
model
model to
to
extract
recognize.
that information
Yes. And it yes.
from a PDF, for example.
Yes, and it needs to know the difference between this is a name and this is a skill.
That makes sense.
Moses, are we on the right track? We're trying to understand how the model works.
Yeah. It's like as exactly as you've seen, like for named entities, like these are the entities, the name, title, role, contact, email, qualifications, experience, skills, and all that. So it should be able like if you upload a CV, extract the text and like identify, like and categorize all these entities.
Mm-hmm.
So where
Yeah.
is your model
And
getting
then
it wrong?
yes,
When you have an accuracy of 50%, is it that it's misclassifying the name as a skill or the contact as a
no,
skill?
that is like the match. That's like how it is matching like the skills on the CV and the skills extracted on the job description.
Okay, let's
It's
go to
giving you like a
model
50% match.
performance. Where was it getting wrong? Where was it getting it wrong?
Okay, for the model performance here,
Mm.
yeah, so you can see like skills I was getting like a 0.92 like precision and all that. Yeah, okay, on some entities there was overfitting, which is like quite common for like these transformers. Like if you have a very small data set, because they are very good like at learning and understanding, so they easily overfit. Yeah, so yeah, basically this is like how my evaluation like look like. Hello?
Okay, okay, I see now.
Yeah.
So it recognizes company half of the time, contact perfectly, email almost perfect. That's right. Experience perfect, name almost perfect. Okay, all right.
Okay, okay. So it seems from, again, maybe just to confirm my understanding, this is two levels of this problem solving. The first bit is the name entity recognition, and then the next part, which is the job matching.
Yes.
So that part is not done.
No, he's done it.
The skills
No,
matching.
it's
Yes,
that
on Streamlit. He's
yeah,
done
for the named entities, it should be able like to categorize all these entities
So let's say
in
we've
either
categorized them. What are we
and
matching them
then like
against?
and then
Hmm.
extract like skills from both job description and resume
Hmm.
and match. Yeah,
it.
and
So the
like give
output
you a
of the
match.
model is like a dictionary of skills or a list of an array of skills, right?
No, it's a JSON. I think I should
Okay, yeah,
Okay,
like
JSON is
okay,
fine.
okay. And then what
I think I should
Unaona
like
akaweka
it can
akaweka
show you some of
JD kwa
like the
Streamlit.
extracted stuff. You can
ah
see like okay for the name, okay, there's truncated like it's like a Moses smoke. Okay, the title is good.
yeah,
Okay, the
okay,
role it
that's
was
fine.
not quite good.
Hmm.
Okay, even like the contacts is struggling, but it's getting like most of them
So
and
hapo
all that.
kwa nini imitaji. So you're also passing the job description.
Yes, that's like what it will use to match. Like, see, I've entered a job description here.
Oh, okay, so you put it in terms of text. Okay, that's fine.
Yeah, yeah, yeah.
The other thing I wanted to check, what measurement of similarity are we using for the matching?
Um, see, it's just I'm just using like the skills.
No, but you see, a computer needs to know, like, okay,
Yeah,
is it like some fuzzy matching, or does it have to be one-to-one match? Like, we count in this data set, or rather in this
yeah,
list, we have 41 out of
yeah,
62 things that are matching against the other. So it's more of just
yeah. I think this is like a skill for
it's a
skill
set
matching.
difference sort of thing. Because in
Yeah,
this set we have Tableau, in this other set we don't have it. So it's 10 over 15 that have.
So like take us through how you're actually calculating the score.
Mm.
oh, for the scores, like I believe it's like skills for skill matching. Like it will just list the skills that you have and the skills on the job description, and then like for every that one matches, like it will if like everything matched, it will be 100%. For the missing ones, if you match like half of them, it's like 50%. Yeah, like that.
It's
It's like
the
a set
same.
different,
Yeah.
yeah, set similarity, or yeah, because it has to be really one-to-one.
Okay, thanks, Moses. Last question. How
Yeah,
does it work for does the CV I mean I'm asking if the model is robust in that does the
yeah,
CV it you can only feed it a particular CV, this GATS compliant, blah blah blah. So if the CV has a lot of images or it has tables and that sort of thing, will it still work? Or will the
yeah,
model
yeah. It will work with like even like the structure, like rest in the CV, like that's what they call once it calculate like levels.
Do you have an example
Yeah.
of a CV that has images and that sort of thing?
No, for images, I don't think it like it will work with images. It will mostly work with like PDFs, but even though like your CV,
Is after. So we're going in the data analysis, we're going to see that the original data source had data from 2000 to end of 2017, but it wasn't consistent, of which I'll show you that in the slides ahead. So when I cut down from 2000 to 2004, I was remaining with 1,786 entries. And the data consisted of coordinates, date, UV index, instruments used, agency, of which I dropped all the other columns because they're not relevant to me. I only stayed with date and UV index because that's what I was using for my project. So this is what I was talking about. So over here, it's basically just a visualization of the data from 2000 to almost end of 2017. And you can see from 2000 to 2000 and end of 2004, the data looks very consistent. Wherever you're seeing straight lines, that's where there's missing data. So you can see the whole of 2006, there wasn't any data. If you check 2012, from 2008 to 2012, if I didn't decompose it, but if I could decompose it, there are some areas that are missing data. And also from 2012 to 2018. So this is the period that I decided to work with, and you can see that the data was was mostly consistent, and we were having like a UV index because it's Italy. Italy doesn't get that. I'm guessing that this data was collected not during summer, but during either spring or summer during the cold season, because the highest UV index that was being recorded was around 3.4, and the majority was between 0 to, let's say, 2. So I started with data pre-processing. I was not able to list all of them here, but you'll see the ones that were specific to the models that I used in the slides ahead. So for all the data, I did the train test split. I divided the data sets into training and testing splits. So I trained on 2000 to 2004, and I left out the last 2 months for testing. And then I also did the date time conversion where I was changing the data type, and I did for LSTM, I did the min max scaling to normalize the data for the LSTM model. So the first model that I looked at was the ARIMA model. So this model is usually used for time series by capturing trends, seasonality, and patterns in data. And it consists of 3 main components. The autoregressive component, where this uses past values to predict future ones. The integrated component, this is differencing the data to make it stationary, and it basically removes trends. And the moving average, that uses past forecast errors to improve predictions. So before we start using the ARIMA model, I started by making my data stationary. And I checked for stationarity using the ADF test. So when I used the ADF test to check for stationarity, sorry, I didn't explain what stationarity is. So when you test your data and it has a p-value of less than 0.05, that suggests that the data is stationary, while a higher p-value suggests that it's not stationary. So on your right, you can see my results. I got 0.292, of which my data was not stationary. And after I saw that, I decided to apply first order differencing. And this subtracts each value from the previous one by removing trends and making the data more stationary. And after I did the first order differencing, the results, as you can see on the left, my p-value was 0, making my data stationary. And then after that, I ran the ARIMA model. So in the first diagram, you can't see well, that's why I decomposed it. And on the right, you can see how the model performed. It didn't perform very well. It was not predicting any trends or seasonalities. It was basically just a straight line. And the mean absolute error that I got, when I evaluated this model, I got 0.12 for the MAE, and for the MSE, it's 0.02. I know usually that this results, maybe somebody would say they're good results, but I hope you remember that our data ranges from 0 to around 3.4, with majority of the values being between 0 and 2. So the ARIMA model didn't perform very well. So the next model that I decided to test is the SARIMA model. And the difference between the SARIMA model and the ARIMA model is that with the SARIMA model, we add seasonality. So it still includes the same components as the ARIMA model, where we have seasonal differencing that removes repeating trends. We have seasonal AR and MA components to capture dependencies within the cycles and seasonal periods. And this defines the length of a seasonal cycle. For instance, it can be 12 months of monthly data or 6 months of the data. So Sarima first starts by removing trend and seasonalities, and then it applies the AR and MA components to the model dependencies. So over here, you can see how the Sarima model performed. It performed slightly better than my Sarima model performed slightly better than the ARIMA model. And if you look at the MAE and the MSE, they're slightly better than the ARIMA model. But no worries, maybe you'll not remember all these values. We're going to look at a comparison of all the models at the end. So the next model that I tried out is the Prophet model. And this model is good for handling trends, seasonality, and holiday with minimal parameter tuning, and it's also built to work well with missing data and outliers. So the key components of the Prophet model are: the first one is trends. It captures long-term trends and increases or decreases the data. Seasonality, it handles seasons well, such as the daily, weekly, yearly, or repeating patterns. And it's also custom to events such as holidays. So compared to the ARIMA and SARIMA, Prophet is much more flexible and it's robust to missing data, and it also works well for business and economic forecasting, unlike the other two models that we've looked at. So before I run my model, the format that the Prophet model requires is that there's a DS model, that's the date time column, and it stores timestamps, and the Y column, of which from my project was the UV index. So it stores the values that were meant to be forecasted. So down here we can see how the Prophet model performed, and it performed pretty well. If you can see the diagram, and also when you look at the MAE and MSE, the results seem to be doing pretty well as compared to the SARIMA and ARIMA models. So the last model that I did is the LSTM model. Just hold on 1 minute. So the last model that I did is the LSTM model. And this model is designed for sequential data and solving vanishing gradient problem. And it's mostly used, all the models we've used are for time series forecasting. So the key components of this model are the forget gate. So this gate decides which past information to discard. Then we have the input gate, and this gate determines what new information to store. And the last one is the output gate, which controls what information is passed to the next step. So over here, I have a visual representation of how the LSTM model works. We've looked at the description of the input for get gate and output gate, and you can see how it works. I don't take time here. Let me move on because of time. And here is just a breakdown of how the LSTM model works. So first of all, it starts by creating sequences that capture temporal patterns, and it ensures that X features and the targets are properly shaped for the LSTM output. The second step was model creation. So I stacked LSTM layers with dropout and L2 regularization to prevent overfitting. And I also compiled it with the Adam optimizer and MSE, and as well as MSE for the loss function, and for evaluation I also used MSE and MAE. We'll see that in the next slide. And the third step was model training in the early stopping to reduce LR on plateau for better generalization. And the last step was the prediction and evaluation. So this is how my LSTM model worked. And from what you can see, it's pretty accurate. Okay, from the results, it looks like it's lagging a bit. I tried putting it in line with the actual test data, but it wasn't working. I was still getting something similar. So I decided to stay with this. But on average or in general, it performs better than all the other models that we've seen, of which we're going to see ahead. So this is the evaluation metrics I was talking about, where we compare the MAE, MSE, and RMSE for all the models that we've looked at: ARIMA, SARIMA, Prophet, and LSTM. So if you look at the LSTM, just scroll down. So if you look at the LSTM, it's the one that performed the best. We have an MAE of 0.06, MSE of 0.1, and the RMSE is 0.08, of which if you compare with the rest, that's Prophet, Sarima, and Arima, it's the lowest, which means that it did perform the best. And also if you look at the MAE and MSE, for the Prophet model, it was lower, the MAE was lower than for LSTM, which shows that it would have performed the best, but once you square the MSE, you get 0.12, and it didn't perform that well. So basically, this is just a comparison of all the models, the evaluation metrics of all the models. And LSTM performed the best, with Sarima as the it's not Sarima that was the second best, but the second best. Okay, according to the results, yes, Sarima was the second best, then Prophet, and then Arima performed the worst with the highest MAE, MS, and MSE. So from here, there's this bit that I forgot to put in the presentation, so please bear with me. So from here, this is where the functionality of my application comes. This is the chart that I used to rate the UV index that I got it from Wikipedia, where 0 to 2 is low UV index, and with that you need an SPF, sunscreen with an SPF of 15. 3 to 5 is moderate, and the SPF for sunscreen would be 15 to 30, and 6 to 7 is very high UV index, and 8 plus is extreme, of which for 6 to 8 plus you'd need a sunscreen with SPF above 30. So as for the CSV with the sunscreens, sorry, I can hide this. So as for the CSV with the sunscreens, it was just a personally curated one. I just collected sunscreens and the SPF, and I took that data and I put it in a CSV file, and that is what I used for the recommendation. So from the data that we saw, the UV index was pretty low. The highest was around 3.4. I think it's because of the country and the season that they decided to collect data in. So over here, we've predicted this UV index using the LSTM model because it was the best performing one, and we got a UV index of 0.19. And from the chart that we saw above, we can use a sunscreen with SPF power of below of 30 or of 30 and above, but also that a sunscreen with an SPF of 30 would suffice. So this is how it works. It gives you the prediction of the UV index, and it also looks at the SPF power that, according to the chart that I showed you above, it compares the values and then it recommends for you a sunscreen with that SPF power. So I was thinking of, let's go back to the presentation. So I thought of making of deploying this app to Streamlit, but it wouldn't make sense because all the values I was getting are from a station, and they weren't area specific. If the area specific, it would have made more sense, like where on the app you put the name of the location, and with the location name that you've put, it goes through the data that's available, and from that data it does the prediction and it recommends for you the sunscreen. I had an issue with getting data, and this data I got initially, the idea was to use that data to train my models, and then I tried looking for future data for now the application bits. So project can be, but I was unable to get future data. So those are my challenges. So for future enhancements, I'd like to do global coverage with more specific data, probably from an API. And it would also make sense that I have real-time updates of that data. And this would be an added functionality, the personalized recommendation based on someone's skin type and location, as well as weather conditions. That would be an added functionality on the app. Yes, so that's my presentation. That's my project.
Absolutely brilliant, Naomi. That's a good project. Mercy, do you want to start with the questions? Do you have questions?
Okay. I think I'll start with like some kudos, like really good readme. It's even if you wanted to present your readme, you can totally do that. It's well outlined, it has flow, it has the images. Also very good, and both to you and Moses, very good aligning your model to a business case, right? You're not just doing machine learning, right? For Moses, he's not just creating a resume parser, he's creating a resume parser in order to then do an extra calculation, which is the matching of the skills. And then for you, Naomi, you're not just predicting the UV index, you're predicting the UV index so that the end user can be able to know which sunscreen they should purchase depending on where they're going. So, really good aligning those two. That's typically how machine learning should work, right? And then the one thing I'd say is, and it for me, right? I guess maybe the assumption is that you're presenting to your technical mentors, they probably know these things, but it's always a good idea to situate your model and your explanations to the context of the problem. So when you say something like Arima has this, like, okay, let me give you an example of where I was like, okay, I'm a little lost here. When you're talking about the Sarima input, it Arima removes seasonality, correct me if I'm wrong, right? And then Sarima brings back the seasonality. Like, what does that mean in the context of UV prediction? Like, can you imagine you're speaking to an audience of people who have never written a line of code in their life? How would you break down the concept of seasonality in this context? And then why are we removing seasonality in one and then inputting seasonality in another? And then we are finding that one has a better performance. What is it about seasonality that influences one model to perform better than the other, right? That's actually a question I'm genuinely curious about. And then for EDA, I feel like the EDA is lacking. Like, you would have done so much. I was so curious. In the 2000, which month was had the highest UV index, or which day? You could even annotate your. You could do a monthly analysis. You could annotate your graphs and showed us those spikes in those years. What particular day were they, right? And then you also say that um, in the beginning you said, I think this data was collected in the spring, but you have the data. Show us. Was it collected in the spring? Was it collected in the summer? And all those things would have been revealed if you did like thorough EDA, right? Instead of telling us, I think it was done in the winter or the spring, can we show a break? Can we see a break? So you had a date time column, so you could
Yeah.
totally extract the month and showed us it was hottest in January, it was coldest in December, and we could see, oh yeah, it's typically cold in December because of this, blah 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 blah, and all those things. So EDA was absolutely lacking. I don't even think you did EDA, right? So I think very good project. Even me I was like, am I using the right sunscreen? Maybe. I hope so. But yeah, I genuinely want to know, like, what do we mean by seasonality? I didn't quite get um, what that means and what that means in the context of this project. And then what's the difference? How come when you input seasonality in another, it performs better, and so on and so forth. But overall, really good, really, really good project. And also very good use of different models. Like, okay, I used this, I got this, I used this, I got this. Very good. Very good use. Right?
So, Nami, do you have a quick answer for Mercy's question?
Yes, I do. And I'll start from the first question okay, the one, the comment that you made about the EDA. Okay, I agree, I didn't do enough EDA. Though I looked at here in the data analysis, I looked at I personally looked at it. I didn't include it in the README or in the presentation. I looked at when we have spikes in UV index, and when we have spikes in UV index was during summer. And where the UV index was lowest, that was during winter. As it goes up, that's spring. Maybe I should have added that in the presentation. And you're asked
You could
the
find
next
that those spikes are actually errors. Because how would we?
Just on a day, a single day, yeah.
Just a single day is very quiet. Like a
Mm.
random spike, that could be an outlier that you needed to remove. Right?
Okay.
Just one random day, it's at 50 degrees Celsius. That's quite odd. Yeah, and those things you could have picked out with a proper EDA.
Yeah, maybe that's an area of improvement that I'll look into. And you asked about the Arima and Sarima model and why Arima model performs better when you add seasonality. Is that correct?
Yes, yes, please.
Okay. So the ARIMA model works by capturing trends and patterns, seasonality in the data. And the three components that are listed here are the ones that it uses to study the patterns in the data and forecast the data. So from my understanding of how ARIMA works, yes, it can yes, you can use it to predict data, but it does not capture seasonality well. It doesn't capture seasonality well as compared to Sarima. And when we come to Sarima, seasonality, oh, I'm sorry. And actually, when I differenced the data, I'm sorry I didn't include that visualization here, but when I differenced the data, it removed seasonality. And that's one thing we can look at. And I didn't do the same for sorry. And as for Sarima, we have seasonal differencing that removes repeating seasonal trends.
You see, this is what I mean, right? Like, what does seasonal differencing mean in the context of this project, right? Just go back to
Okay.
Arima. Like, this is what, for somebody, I also don't have a lot of like experience um, with time series analysis. That's why it's better to situate everything you're saying into this project, into context of the problem. For example, you've said Arima model is for time series forecasting, yada yada yada. And then you say you're now breaking down the components of the model. So you have autoregressive AR, it uses past values to predict future ones. Instead of saying that blanket sentence, I would say it uses the past values, it uses past UV indexes to predict future UV indexes. You see, that small difference contextualizes what AR means, right? Then we have I integrated, differentiating data to make to remove trends. Like, what trend are we removing in the context of the UV index? What are we referring to as the trend? Now, if you explain it like that, it becomes so easy to understand what exactly is the model doing, right? So now I can understand your output and your input much better. Is it is it making sense? What I mean by contextualize your model to your problem.
Yes, I understand what you're saying.
Yes, not just
Instead of
don't tell us a
generating
definition.
the notes, I make them,
Uh,
I bring them home to my project.
exactly. And then everything about the content you're presenting here, even the written content, should mirror that, as opposed to telling us this is what AR means. What does AR mean in this context? This is what integrated means in this context. This is what a moving average is in this context. Once you do that, I literally can understand, okay, the model was doing this, and this. Great. Then this other model, it does this, and this. Great. Is it that's all. Okay. And even when you go to present to your bosses, they don't want to know, okay, AR is this. They'll want to know what is AR in this thing that we are doing here. And it also helps you understand your model and do error analysis much better. If you understand in the context of this problem, what is my model actually doing? Okay.
Yeah.
Yeah, but all overall, very good project. Really good. I just send me the Streamlit. I This is something I will use.
Okay.
Okay. I think I don't have much to add. Yeah, equally a good project. I think I just have a couple of questions for you. Are there any other environmental factors that affect UV index aside from the regressive nature of this data, where you expect today's index to depend on yesterday's measurement, etc.? Are there any such environmental factors?
Yes, there are.
Yeah.
So, for instance, I took this data is data from Italy.
Yeah.
If I used data from Kenya, considering the fact that our country is on the equator and the weather conditions are different, we'd be seeing different results. So there are actually very many weather conditions that affect the UP index and also other stuff besides weather conditions.
Okay. Because perhaps that we can close.
Chris, on my end, power was gone, but I'm back now. Can I present?
Yes, please.
So, can you see my screen?
Yes, I can see.
So, my project was sentiment, Kenya Airways customer review sentiment analysis. So that's the business overview and the business challenges, understanding passenger satisfaction, drivers drives in a competitive market, managing brand reputation in the digital age, and identifying operational pain points from customer feedback. So the project overview was the project aim was to conduct a comprehensive sentiment analysis of customer reviews related to KQ and extracting actionable insights that can drive service improvements and enhance overall customer satisfaction. The key objectives were sentiment classification, to develop models to categorize reviews as positive, negative, or neutral, and feedback analysis to identify recurring themes and specific service aspects mentioned in reviews, and the actionable insights. The actionable insights were to generate recommendation based on sentiment analysis findings. So the expected business impact was as follows: enhanced customer satisfaction through targeted improvements, more efficient allocation of resources to high impact areas, data-driven decision to make for making service enhancement, and to offer competitive advantage through responsive customer service. So my project methodology was, as you see, data collection was through scrapping data from airquality.com, and then there was data cleaning, converting dates, removing stopwords, and lemmatizing text using NLTK. Then there was exploratory data analysis, that was word frequency analysis, visualizations of word clouds and others like histograms. Then there was sentiment analysis using VEDA to classify the reviews, and model training. So I scrapped the data from airquality.com, performed date conversion and standardization, removed stopword using to focus on a meaningful content, applied lemmatization to reduce words to their base forms, and then implemented text normalization techniques, created term frequency matrix, used count vectorizer, and then there was the analysis and modeling. I conducted a EDA on review content, generated visualization, including word clouds and histogram, used VEDA, and then trained multiple machine learning models. That was logistic regression, decision tree, random forest, and SVM, support vector machine. Now, so on model performance, I did on the best performing model was logistic regression and SVM, but I settled on logistic regression, which had an highest accuracy of, here it's saying 84%, but on my on my on my Google Colab on my Jupyter notebook. I started it. It started on 84, and as I rerun it, like now it's 74%, but it's still the highest with the highest accuracy. So my main reason to use logistic regression was better interpretability compared to other complex models, and computational efficiency, clear decision boundaries for sentiment classification, and ability to handle the class imbalance in neutral sentiments. Then there was sentiment analysis results. The common themes in negative reviews were flight delays, comfort issues, customer service, and booking and refund process. And then there were common themes in positive reviews. In my word cloud, they were friendly crew, value for money, meal quality, and entertainment options. So these were the key insights and recommendation on my project. Operational improvement. One was punctuality enhancement, review and optimize flight scheduling, ground operation maintenance procedure to reduce delays, to implement better contingency planning for disruptions, customer service training, develop enhanced training program for staff, focusing on empathy, problem solving, and consistent service standards across all touch points. And then there was comfort enhancements. You should consider phased cabin upgrade, particularly focusing on seat comfort, legroom, and modernizing older aircraft in the fleet. So the implementation strategy should prioritize on quick wins, addressing immediately fixable issues in customer service and communication protocol, develop action plans, establish metrics, that is, define success metrics and regular monitoring procedures, and continuous feedbacks to implement ongoing sentiment analysis to track improvement progress. Then there was communication strategy, that is proactive updates, digital engagement, feedback systems, and there was the expected business impact. Customer satisfaction projected 15 to 20 in positive sentiment metrics within 12 months. Brand reputation, improved public perception on social by Q3. And then there is customer loyalty, expected 8 to 10 increase in repeat bookings within the fiscal year. Operational efficiency, reduction in complaint handling costs through proactive resolution. So my conclusion and for the project was like this. The key achievement was I developed a sentiment classification model at 84% accuracy, identified critical service areas influencing customer satisfaction, created a data-driven recommendation for operational improvement, established a framework for ongoing sentiment monitoring. This project demonstrates the power of data science in transforming customer feedback into strategic business insight, creating a pathway for KQ to enhance its service quality and brand reputation. So future expansion should be real-time sentiment monitoring, competitive benchmarking, predictive analytics, and so this is my conclusion for the project. And then I had a dashboard which doesn't say as much, but it's only like this: Kenya Airways sentiment customer review. So these were the sentiment distribution: neutral to 25%, positive, negative. Key topics mentioned: customer service. These are negative sentiment, is an area to improve on. Flight delays, cabin crew, that's a positive sentiment. Another neutral sentiment on baggage handling, and so forth and so on. So My key findings for the project was customer service issue. That was a negative sentiment, and in-flight experience was a positive experience. So they shouldn't work much on that. And then flight delays was a negative sentiment. Baggage handling was a neutral one, and booking experience. So my research methodology, data collection was based on I corrected the data from multiple sources, including TripAdvisor, Skytrack, social media platform, and Kenya Airways, like that, from January 2022 to I think to December 2022. So these are the techniques I used. I employed NLP, including BRT, topic modeling with LDA, named entity recognition to identify specific aspects, and word frequency analysis to identify key concerns. So that is my project.
Okay. Could you take us to the methodologies? Because that's really not coming out clearly here. Why not on the not on this, not on the, but more on, you see, when we are making a presentation for machine learning project,
Yeah.
the
Yeah.
EDA part you've done well, but something that's not clear is um, what what were the features that you fed into the model? What was the data label like? Was it a multi-class classification problem? And then what were the class separations like? So yeah, you can start there maybe with the features um, and the data label.
So I started like that. First of all, I scrapped my data using Beautiful Soup.
Okay. So what was the data, the output data?
The output data, they were just, it was, I made it I created a data frame and saved it in a CSV format.
Okay. So
Yeah.
this was the data frame that was the result of your
Yeah.
scraping.
This was the data frame to 15th March of 2025.
Okay,
So I
so
saved
we
the
have a
data.
date component, and then we have
The
verified
reviews.
reviews and
Yeah.
verified reviews. And then within these reviews, it seems there is some bits of columns that we are looking at. Did you clean it to say, um, what is in these reviews? Because it seems the first column is if it's verified or not. Go on.
So as I scrapped there were those that said the trip was verified and the others which were not verified. So me, I just put the data in a collective format, because all in all, these were the feedbacks from the customers. So
Let me call you back in 10.
what I did is just
Hello, can I call you
I
back in
just
10?
put the data
It's
in a
in 10
CSV
minutes.
as it is.
So now, Richard, where did you? Okay, so because the EDA, this, how have you cleaned this data so that you can now feed it to the model? Like, what data did you feed to the model? And also, where did you? At what point did you classify a sentiment to be positive, neutral, or negative? And how are you coming up with that? That's what I'm interested in.
So yeah. Let's go to that. So first was the distribution of review and word count.
That's
This was
okay.
my first. This was my first EBA.
What does it show you?
This one shows. Uh, this shows the word count of per review.
Yeah, but what's the insight? Because we can see, remember data storytelling, we can see the graph, but what is the conclusion? What is the insight that we are deducing from the graph?
What I can deduce from the graph is that my word count from the reviews, the total word count was at most was 100 to was from 50 words to 200 to 150 words per review.
Okay, let's
Yeah.
go on then.
And then I did the data pre-processing. These included like removing special characters, optimizing text, eliminating common words, and handling negations and converting text into numerical vectors.
So what are negations, and also what is stemming and lemmatization? Because remember, in the presentations we've kept on asking, what do you mean by tokenizing? Remember, you're not presenting to an audience that already does NLP, so you can tell us, okay, a tokenized
So,
text looks like this. Common words that we're eliminating are like the, etc. Why are they not important? Why are we doing stemming? Why are we lemmatizing? And what are negations that we are handling? That's now what we need to see. Can you take us through that?
so what I did was, as you are asking, the common words are just like them in, and for.
Okay.
Yeah, and tokenizing them is just putting them in batches, yani naiweka tu pamoja, yani natoa hizo common words ndio nibaki na zile words muhimu
Yeah, but
kwa
why are
kila
we doing that? Is it that the model requires that? So that you need to explain like that.
yeah.
And why are we eliminating common words? So the why is what is important here, because somebody will
So that
ask
I can
you,
be
okay,
able, so
yeah,
that I can be able to classify my sentiment as negative, positive, or a neutral sentiment.
okay, but still there is some more explanation you can do on that. Like when we leave them, what happens? Does it not classify? Yes. So that the why really needs to come out clearly. But let's go on. So after data preprocessing,
So I came with
so this
the
is the data that you have, whether it's been verified or not, the date, the word count of the review,
yeah,
and then the review itself.
yeah.
Okay, so let's go on. Okay, so how are you creating a corpus? And what is this corpus? What does it mean?
Corpus is basically uh, I wanted, yeah, corpus waga ina convert sasa sentiments zangu into categorical variables. Why either one ikiwa positive, zero ikiwa negative, kitu kaa hiyo. Kucreate a
No,
new column. Corpus ni kucreate another column.
but how? Like what's yeah, creating another column can be to do very many things, but how are we creating that new column? What's the difference between the reviews column and the corpus column? Because it seems it's important to your sentiment classification, and the words are slightly different. Because remember, if you can see the number 500, it says, I flew Kenya very often.
Where?
The last one, the last, yeah, I flew Kenya very often, almost once every 2 years. But then in the corpus, it's like fly Kenya often, almost every week, usually business trip. So it's slightly different. It's speaking the same language, rather the same message.
But the
Yeah. So what
kuna
is that
words
language corpus or whatever corpus analysis doing that's not coming out?
imetoa sasa zile common words. Imetoka na, yani hiyo ndio tokenization.
No. That's not tokenization.
Ni nini?
How would I know? But I just know it's not tokenization. Because if you look at 496, this person has flown from Johannesburg to Nairobi to Johannesburg. And then they are saying trip showed both the good and something something. I'm not sure like the entire detail, but the corpus explanation is slightly different. You get? So there is something that's going on, and that explanation is what we require. Yeah, let's go on. Let's go on to the NLTK part. What's happening at that point?
So so hii sasa NLTK ndio natural language processing toolkit,
Okay, so what is it doing?
ndio niweze kutengeneza vitu, yani kutengeneza sentiment zangu sasa, ndio niweze kujua kama ni negative, ni positive ama ni neutral.
Okay, that's fine. But this NLTK library, does it mean whenever I pass something, it gives me whether that sentiment is negative or positive? Is it right? Is that right?
Hapana.
So what does it give me, and how does it come up with that? Like, how has it been trained or tuned, or maybe what's in the background such that it can give me that score or that polarity score? Like, how does it end up with something like negative 0.7 and sometimes says positive 0.9? How does it come up with that? That's my
Okay.
yeah, that's my question there.
Okay.
Because it seems that's how you're classifying your sentiment, and to a degree they are right, because they say, oh, on board service is good, that's a positive sentiment, but like, what's the explanation behind us labeling that as 0.82? So that is missing,
Okay.
and I don't know if you have it. That's what I'm asking now.
I don't have it right now.
Yeah, because that makes therefore the project incomplete if we cannot realize, because we can't also tell which ones were negative and were really just classified as positive. You get? Like,
Yeah.
we can't say if somebody says, and these people are bougie, like, can we really tell if that's a positive sentiment, or maybe they're being sarcastic, such like things. So
So hizo sentiment ndio ikiwa positive, inakuwa ni hebu kidogo tu nitakwambia before tumalize hapa hivi, kwa sababu I have the other presentation for hiyo nini ya logistic na yenye nilifanya nayo sasa, hiyo logistic regression ndio sasa, hiyo ndio ina explain kwa nini yani inakuwa negative, yani ndio na minus na kwa negative na positive inakuwa ni bila negative hapo hivyo.
That's fine. So let's go on then. So, okay, let's go on.
So hapo ni kucalculate nini sentiment score.
That's fine. That's fine. So
There's
most of the
sentiment.
reviews, okay, there's a balance between positive and negative in this one. And after you've done the passing to an LTK, but where are the neutral ones? Because I saw them in your analysis. At what point do we?
Ziko hapa chini.
So how did we get some that are neutral?
I have some neutron. I have one over here.
Okay, so what qualifies for a neutral sentiment? What's the percentage, or rather, what's the score that makes something neutral?
If score is greater than 0.2, that's a positive.
Mhm. And then if it is greater than 0.2, it's a positive sentiment.
Yeah, something like that.
And then if it is less than 0, it's a negative. But where
Yeah.
is, I'm not seeing the logic for neutral. And how did we arrive? Because for the 0, less than 0, I can understand. That's a negative. But how did we arrive at 0.2 and not 0 and not 0.1? Like, what's the logic behind that? And even here, I can't see where we are saying now those are the neutral ones, because we have an if 0 point that negative positive, if elif positive, but then where is neutral? So this, where this neutral is coming from is what I'm not sure. Okay, let's go on. Then count vectorizer, what is it supposed to do?
Count vectorizer.
Yeah. Okay, rather take me through the pre-processing steps after the labeling of the neutral, positive and negative.
Hizo zote ziko kwa hiyo presentation ingine.
So there's another presentation on top of what you've given us.
Ya hiyo sasa ina explain hiyo model yangu ya logistic regression, ina explain mpaka count vectorizer, hizo vitu zote zenye ziko hapa.
Yeah, but why would you do a label and then again come again and do a prediction? I'm not so. So are you predicting on new reviews now?
No.
Okay, I could be wrong, but I don't know how that works, where you've already assigned a label and then
Yes.
you come and again do the prediction. Because how that label is coming about is what I initially I actually thought that that the reviews are already labeled if it is positive or negative. That's the only time you can use a supervised machine learning model like the logistic regressions and even the random forests and the likes. Otherwise, uh, it's not a supervised learning problem. Because what if you've gotten some of the labels wrong? How would you know? The other comment I have is on the EDA. I think there is more you could have done there. Well, you've really done a good project right up, but now the work itself is not coming out. So, for example, um, the EDA section and even also the explanations on some of these methodologies, as you can see, we can't get a clear understanding of what NLTK does, what is that corpus. So that is not coming out clearly. But also on the EDA, if we have time component, it's usually very useful that you try to visualize, what is the sentiment over time. Does it mean at some point when KQ, maybe they changed something, they've changed to a new airline or, aeroplanes, and they've overhauled their fleet, there is a difference in the sentiment? Is it swinging positive or negative? Because you have time. You can't just avoid using time if you already have it as a feature. We would be very much interested in seeing that. How have the sentiments trended over time? You get what I mean?
Yeah, I get it.
Yeah. And then something just I observed it's very light, nothing special, but were your colors informed by something on the presentation? The colors,
Which colors?
the blue, green, something like there, red.
No,
Okay, I just got the Kenyan flag there, so I thought maybe you had in mind Kenya Airways and their
no, no,
colors.
no.
Okay. Actually, commendable work on this part of your project. It really is a well done outline of what you did. Now, what's lacking, which you need to work on, is the illustrations of those methodologies and actually deep understanding of what they are doing. And then your model. I'm not so